Hi, hello everyone. My name is John Winford. I am the Global Lead for the Database Freedom Program at AWS, and I'm here to talk today about how you can modernize your SQL 2008 or 2008 R2 instances and basically leverage AWS database services to achieve transformation in your business. So, what are we going to talk about today? In detail, we're going to go over some basic information about Amazon native and open source platforms, specifically around the database services, of course. We're going to then spend a bit of time talking about the migration tooling and how they can help you migrate from on-premises or existing commercial systems that are in the cloud to open source platforms on AWS. Because I know everyone sees a lot of PowerPoint slides and are always much more interested to see how this actually happens in real life, I'm going to spend a good chunk of the time today in a live demonstration showing you just how easy it is to migrate your database to the cloud. And then, of course, hopefully we'll have some time for questions at the end. But yeah, that's enough of the introductions. Let's get started and dive into things. So, as customers move from microservice architectures and build loosely coupled distributed components for their applications, it's important to have the right tool for the job. In the past, vendors, they tended to push you towards one particular product, and that was sort of the answer to everything. Well, at AWS, we don't think that way. We believe that you need to look at your workload and determine, does it make sense to run it on a relational database? Does it maybe make sense to run it on a non-relational system like DynamoDB or even something like Neptune? Or are analytics, are we talking data warehouses? Is this something that would make more sense to have in a Redshift system? And you can see actually right now we've got a bit of a stacked model. We're talking about the different systems across the top. You can look at building a big data lake with something like S3 or Glacier. And then down at the bottom, we're talking about the different services you can use to move data. So database migration service, we're going to spend some time talking about that today, but the reality of it is there's other ways to go about things too. If you're talking about large volumes of data, it might make more sense to use a snowball, for example. Or if you want to move an entire data center, there's always the snowmobile, and I urge you to check out the video from a couple years back at reInvent if you're not too clear what a snowmobile is. So all up, we have an entire platform of applications that are broad and deep, purpose-built for builders. Remember, AWS, we're for builders. We're all about giving you those options to move. So we design products for every imaginable use case you have to ensure you get the optimal scale and using the ideal product for that use case. Our strategy's always been to start with a customer and work backwards. As our product teams worked with thousands of customers over the years, we've got a couple of key themes. We hear over and over that customers want to start small, with low overhead costs, iterate quickly, and have the confidence that their infrastructure and application infrastructure will allow them to scale as they grow. It's been pretty successful too. If you look at our customer list, well, we've got over 500,000, and this is just a small snapshot of customers that are leveraging our database and analytics in the cloud. A lot of recognizable logos in there. Basically, it's been very successful, and while the database and analytics markets have been around for a while, we've got many mature offerings for customers to choose from. You're certainly not going to be the first one, and you're not going to be the last. And basically, we see this for a number of reasons. Customers choose to move to the cloud and minimize the time spending managing their infrastructure. They look to move to the cloud to get performance, scale, reliability, and cost. And, they're looking for 24/7 responsive type applications and applications that they don't have to spend time managing and monitoring themselves. Basically, by letting us handle your database infrastructure in the cloud, it allows you to spend more time focusing on what differentiates you as a business, what gives you that something special. Just because you can run a database on a server in either your office or in a third-party data center, that's not something special. Let us handle it for you. Work on what makes you different from the competitors. The differentiating factor is really where things can accelerate. So we started this at the start of the day by looking at all of the different components of the database and analytics stack. As I mentioned right at the very start, we're here to talk about SQL 2008 modernization to cloud native, open source, or Amazon platforms. Now, what that means is I'm going to stick primarily with the relational type systems. That's not to say that you couldn't migrate your SQL Server to something like Dynamo. Going SQL to NoSQL, very common thing to do. For those of you that aren't aware, if you look at Amazon's website, for example, historically we ran a lot of that on Oracle and a relational system, but now we've discovered a better way to go about it, and that is to use DynamoDB because it can handle things at a scale that was just not possible with a relational system. But, that doesn't make sense for every workload. For a lot of workloads, relational databases are the way to go. And if you look at the numbers out there, relational is far and away more common in the database, and we expect to see it stay that way for many years into the future. And that's why we offer such a wide variety of database options to meet your specific needs. In fact, we offer more options than any other cloud vendor. So historically, databases have been on-premises, and as customers moved to the cloud, they initially leveraged EC2 to run their own databases. With this approach, we still had to deal with all the unusual pains, or all the usual pains, I should say, that accompany on-premise databases, such as hardware provisioning, database setup, tuning, patching, backups, and scaling. Way back in 2009, we launched our first managed relational database service, or RDS, for MySQL. MySQL was already the most popular open source database, and RDS made it easier to set up and use. I mean, frankly, with the click of a mouse, you can start a MySQL database and get it up and going. As customers started to use RDS MySQL, requests came in from other users that were using other on-premise systems. So we created RDS for Oracle in 2011, SQL Server in 2012, Postgres in 2013, and MariaDB in 2015. Add to these services our own Amazon Aurora, which we designed for the cloud from the ground up, and you have the broadest selection of fully managed databases available. So, RDS, what is it? RDS makes things cheaper, easier, and better. Our mission with Amazon RDS is to manage the muck, the day-to-day tasks of running a relational database that keep you from focusing on the things that differentiate you. Instead of having your developers focus on provisioning, patching, and backups, they can focus on meeting your business objectives. The other thing we do is take something very complex, that is high availability and disaster recovery across multiple data centers, and make it incredibly easy. This means you don't have to wait until you're a large organization to be able to have a highly available application. With RDS, features like HA is available on all engines, including the base and standard editions, not just for enterprise editions. So just think about that for a second. You don't have to pay for the high-end commercial database. If you want to use something like a commercial database, you can leverage the RDS specifics on top of that to enable something like HA and DR. That's not to say that you wouldn't get even more flexibility by going open source, but just know that either way you go, Amazon has you covered in the database space. So HA, just to review for those that haven't spent a lot of time with it, basically with RDS, what happens when you enable our HA option, we call this MultiAvailability Zone, if you turn it on, which if you haven't looked at it before, you just go onto the AWS Console and you enable it with a single mouse click, right? So if you turn on that mouse click, we're going to launch an RDS instance in another availability zone in a region. If you choose a single availability zone, of course, you're just going to have one instance. When you turn on multi-availability zone, we're going to launch a second one on your behalf and configure it such that you get an automatic failover from the primary to the standby. Because it's automatic, this is one of these key things that comes in as being a managed service. Now, as somebody in the past who has actually set up an HA configuration on a database manually, complete with log shipping and, backups that ship over the backup file every night and all that sort of stuff, I can tell you being able to do this from a single mouse click on the console is infinitely easier, more reliable, and just saves you days and days in configuration and testing and all of that sort of thing. Really, really great feature of RDS. The other thing that happens, again, going back to the fact that we're talking about a managed database service, is you get automatic backups. When it comes to backups with RDS, you get one scheduled backup a day. You can choose what time window is appropriate for you in regards to your backup window. And along with this, since it's a managed service, you get all the monitoring of the backup jobs to make sure it completed successfully and that it's executing on time. Making sure the backups are happening can be a big operational burden if you're doing this on your own. So again, you're saving a lot of time here. With MySQL, Postgres, Maria, Oracle, and SQL Server, these backups are of your entire instance and your transaction logs. You get to choose how long you want to retain them. In order to ensure durability and availability of your backups, the service keeps multiple copies of your backup in each availability zone where you have an instance deployed. When it comes to Aurora, things are a little bit different. With Aurora, essentially the backups, you don't schedule them. Everything's automatically backed up continuously to the storage environment of Aurora. Just like with the other engines, you can configure the automatic backup retention period up to 35 days. And with Aurora, your backups are stored in S3, so you get the benefits of S3's availability and durability. You don't pay extra for using the 35-day backup retention, so why not take advantage of it? It's pretty straightforward. So we've talked about HA, we've talked about backups. What about scale? Well, in scale, we have what we call read replicas. So when your master database becomes overloaded in trying to handle read and write requests, you can either try and scale the master itself, or you can take the path of adding read replicas to handle the read workload. With RDS, read replicas do a couple things. First, they allow you to create read-only copies of your master database that are kept in sync with your master database, and then you can point your read queries from your applications or end users at these read replicas to help keep the read workload on your master database low. Depending on the database engine, you can also place your read replica in a different region from your master, which may give you the ability to have a read closer to a particular locality. Finally, read replicas give you the ability to have another avenue for failover when there's a problem with the master, giving you the ability to have coverage in the event of a disaster. So I've talked a little bit about regions and availability zones before. For those of you that aren't familiar with the concept, a region for AWS is like a geographical region. So pick somewhere like a city, if you will. So in a given city, we have a region, but that region is made up of multiple availability zones. So at the simplest form, think of availability zone as a data center. So clustered around a city, geographically separated by give or take 50 miles, you're going to have multiple data centers all forming a single region. Scalability. So what happens? If you're doing things on premises, you probably need to factor in what do we think the database is going to grow to over the next X number of years. In the cloud, you don't have to do that. Scaling is pretty easy to do. You can only think about here and now, and if you need to scale up or scale down in the future, you can do that automatically through the console. This example on the screen, it's Aurora, but basically how it happens is pretty similar for all of them. You can scale up and scale down by choosing your different instance class. Actually, sorry, the screen is MySQL, but basically what happens is you can scale up and scale down on demand. And with Aurora, the main difference is that the storage scales automatically, and you don't need to do that yourself. At AWS, security is a top priority. Being able to secure your database environment is very important, and there are many features within RDS that allow you to achieve the security profile you're looking for. These include Amazon VPC, IAM for resource level permissions, encryption for data at rest with AWS KMS, and in-transit with SSL. You put all of these things together and you end up with a very secure environment, and we've got all manner of security certifications by third-party independent organizations should you require these things. Starting from the customer and working backwards applies to even the most mature technologies in the most mature markets. Let's take relational databases as an example to start with. As we talk to hundreds of enterprise customers on the relationships they have with their database vendors, they all talk about how they feel locked in by the providers, that they're expensive, they have proprietary offerings, they have punitive licensing terms, and oh, by the way, you occasionally get a mail that says you're being audited. They're outright hostile to customers, and customers are tired of it. They want freedom. Particularly from one vendor you all know and love, a vendor that earlier this year published an update to their cloud computing licensing policy that effectively doubles the licensing costs for many of their customers who run on the cloud. Doubling prices for customers on the cloud they choose. A company that would do this is not just the most customer hostile IT company, but also the most customer hostile company in the world. It's something we see from all sorts of commercial vendors. They want to keep you locked in. They want to keep you paying software maintenance, assurance, all sorts of nice terms they'll give, like we'll give you support. Well, support at their price on their terms. That's why we get this feedback from customers. They want the freedom to migrate, the ability to choose another system. We've got lots of options at AWS, like we talked about earlier, but Amazon Aurora is definitely one that we highly recommend. Now, to be very clear, Amazon Aurora is a 100% MySQL or Postgres SQL compatible relational database. What this means is you can choose to leverage the power of Aurora, and for whatever reason, if you're not happy with it, you can go right back out and take that same database and run it on an open source MySQL system in your own data center, no problems at all. What Amazon Aurora does is take the open source nature of MySQL and PostgreSQL, build a relational system for the cloud, combine it with the performance and availability of a high-end commercial database, and the cost of an open source database. What this does is this gives you commercial performance. For example, Amazon Aurora is up to 5 times faster than a standard MySQL database or 3 times faster than a Postgres database. We also build in the security, availability, and reliability of commercial grade databases using all of those technologies we talked about earlier, but at 1/10 the cost. Now just let that sink in for a second, 1/10 the cost of your commercial database. Aurora is fully managed by Amazon RDS, which automates all the time-consuming administration tasks that we talked about earlier. It's fault-tolerant, self-healing, scales up to 64 terabytes per database instance. You can scale by using up to 15 low latency read replicas. You get point-in-time recovery, continuous backup to Amazon S3, and replication across multiple availability zones. So, if that wasn't enough to convince you, maybe I'll just mention this little detail, that if you are running SQL Server 2008, basically the end of life is near. Microsoft announced the end of life for Windows 2008 and SQL 2008, and the countdown is on. Beyond these dates, customers that don't upgrade will be out of compliance and exposed to security risks. Of SQL Server users, roughly 50% of them out there are running SQL 2008 or 2008 R2. So if this includes you, don't worry, you're not alone. Now, of course, you could upgrade to a newer version of SQL Server, but you'd still be using an old world commercial database. You'd still be paying licensing maintenance, be locked into proprietary systems, and be subject to audits or what they call true-ups if you want to sugarcoat things. This is on top of using a database that is not built for the cloud. Remember, all the databases we've talked about today are available with on-demand pricing, and what that means is you only pay for what you use. Turn it off, you stop paying. Plus, when you leverage the economies of scale that come with running in the AWS cloud, you pay many magnitudes less per hour than you would if you were operating in your own data center. So if all of that sounds good, it's probably time we talk about the migration tooling and how it is you would move from one system, like SQL Server or Oracle, to an open source system, whether that's RDS, MySQL, Postgres, MariaDB, or Amazon Aurora. And remember what I said at the start. We're all about you choosing the right database for the right workload. We're certainly not going to say you should use one or the other. So at AWS, we believe in being responsive to our customers. They asked us for a long time to make migrations easier and less intrusive, and they wanted migration with minimal downtime to any RDS engine. After migration, they wanted us to enable ongoing synchronization, be able to sync between on-premises and also between engines. They, of course, wanted low-cost migration tooling that didn't require expensive consulting resources or, say, paying 5 figures to purchase the migration software. All of this mobility addresses the biggest request we've had, the ability to migrate off commercial license-intensive database engines onto cloud-native, non-commercial engines. So it's all these factors in mind we designed the database migration service. We wanted it to be simple. You can get going in less than 10 minutes. When we designed it to enable near zero downtime migration. We want it to be a bit of a replication Swiss Army knife, if you will, to replicate between on-premises systems, RDS, EC2, and across database engine type. And to just reiterate that AWS doesn't believe in vendor lock-in, if you want to migrate out from Amazon Aurora back to your on-premise commercial database, you can use DMS to do it. Try finding many other products out there that, that let you have this kind of mobility and flexibility. So when are you going to use DMS and SCT? Well, they can help you modernize, migrate, and replicate. Modernize, converting from one database engine to another, and update the associated application code using the code conversion features of SCT. So that's what we're going to look at today. Migrate, you're looking to move data from A to B, whether this is on-premise to the cloud, between EC2, RDS, or between database engines. And you can also use DMS to replicate. So you want to maybe have a data lake going, replicate changes through on a daily basis. You can use DMS for this, in addition to keeping a source and target in sync during a standard migration. When to use SCT? So basically, DMS and SCT can help you modernize, migrate, and replicate. But there's a couple steps in there. So SCT will actually convert your database schema for you first, before you use DMS to move your data. DMS doesn't really convert schema. It's all about being a data mover. So if you need to convert, say, your SQL Server schema to Amazon Aurora, you would first use SCT to convert that schema, and then you'd use DMS to move your data. As a bit of an aside for anyone that has an interest, things are a bit different in the warehouse space. With SCT, you actually do both the schema and the data movement for data warehouses like you see at the bottom of the screen. The reason behind that is, although DMS has no upper bound on the amount of data you can move over the wire, the reality of it is data warehouses are generally very large, into the multiple terabytes, even up to petabytes, and it's better to use SCT as a local client to dump the data out to disk, compress it, and then move it to Amazon Redshift. When do you use DMS? So DMS is all about moving the data. You can migrate business critical applications. You can move from the old classic networking infrastructure we had at AWS to the newer VPC model. You can use it to move data to Redshift, if you're going from a relational system to a centralized data warehouse. You can do minor version upgrades. So in the RDS console, you can upgrade from one version to another, but it still incurs a minor outage during your maintenance window. If you can't afford even a couple seconds of outage or downtime, you can use DMS to sync between an old version of a database and a new version of the database. You can consolidate shards in Aurora, and you can go from SQL to NoSQL and vice versa. But again, we're going to be talking primarily today about migrating between SQL Server and another relational database. So how does it work? Well, basically DMS can enable near zero downtime migration. How it starts off, if we look at this example on the screen, you see we've got customer premises on the left and AWS Cloud on the right. Remember I mentioned that DMS can go between systems in the cloud, so you can go from RDS to, say, EC2 or EC2 to RDS, and you can also go from the cloud back to on-premises. So essentially, where it says customer premises and AWS, just look at this as source and target. You kick off by spinning up a replication instance in your VPC. A replication instance is basically just an EC2 box with some replication software on it, except you don't ever connect to it directly. We monitor it and maintain it ourselves, and you interact with it through the AWS Console or the CLI. Once it's up and running, you establish a connection to your source and target databases. So this could be really looked at as simple as an ODBC connection. IP address, username, password, that sort of thing. Here's how you make the connection. It's all done securely through either VPN or Direct Connect, something like that. That's not to say it has to be done securely. You could do it to some open port somewhere, but obviously it's not something we'd recommend. You're literally just establishing a connection. So after you've done that, you say what it is you want to move. DMS is a logical replication product. What this means is we don't copy things down at the bit level. We're not copying bit by bit from one database to another. We are literally querying the data out and inserting it into the target. What this means is you can select only certain tables, schemas, or databases to move. You don't have to move everything. Then you sit back, relax, and let DMS create the tables, load the data, and keep them in sync. Now, to be clear, it only creates the tables if you haven't pre-created the schema. Best practice is to use the schema conversion tool to pre-create the schema, and then DMS will just populate them. Once you're happy, you've done all your verification, your testing, what have you, at a time that's convenient to you and your business users, you just need to switch your applications over to the target at your convenience. And this could be something as simple as a DNS update. So you do that, and then you're done. Your migration is complete. So at this point, you're probably going, oh, that sounds too good to be true. Surely it's more complicated than that. Well, the next bit of this session, I'm going to walk through a demo and show you how to actually convert a SQL Server database to Aurora Postgres and the associated application. So I'm just going to quit PowerPoint, switch over to the demo, and show you just how it works. Okay, so now everyone should be seeing my remote desktop session. On here is just an EC2 box that I have running in the cloud. You could just as easily do all of this from your servers or your own personal desktop. I just choose to do everything this way. No particular reason. So right now we have the AWS Console up on the screen. We're going to be looking at a few different services today. But first and foremost, I want to show what it is that we're going to be migrating. So I'm going to kick off and launch the query tool that I like to use, which is called dbeaver in my case. I like dbeaver just because it lets you connect to all sorts of different database engines, not just one in particular, but you can use any query tool you want. No real difference here. So the database we're going to be migrating, as I said, we're going to go from SQL Server to Aurora Postgres. So I'm going to connect to my SQL Server database, go in, choose the demo database, and again, obviously, we're looking at sample applications today, so things will be very different for you, but the same idea holds true. If we go in, look at this this database, we've got a few different tables. We've got some data in here. I'm just going to read it out so you can see. Yep, there's some information there. Maybe we'll also have a look at the orders table just so you can see that we are definitely looking at a real database with some data. And not only that, as part of a database migration, you've got your database tables, you've got your data, but you have all the other schema objects as well. Now, purely for demo purposes, I went and created a procedure because this demo database didn't really come with any. I've called it large order. So all this is going to do is return orders greater than a certain value. If we just have a quick look at the procedure, just so you can see how it works. Again, very, very simple procedure, but all we're doing is looking at the customer table and returning records that are greater than the threshold specified. So if we want to see how that works, I'll just switch back to here. Just going to make sure I'm pointed to the right database, and we will go and run it. So exec. All right, so we're just going to run the procedure, say I want all orders greater than $500 in value, highlight all the record, the whole statement, and execute it. And you can see we've got the same, or basically we've got the data queried from the same table, but now we only see records greater than $500. So that's my source database on SQL Server. I'm wanting to migrate to something more modern, a cloud-native database, if you will. In this case, I think I'm going to go to Aurora Postgres today, but you could just as easily use our tools to go to another engine. You could use it to go to RDS MySQL, for example. Just to prove that there's no funny business going on, I'm going to show you my Aurora target database here. I have an empty database with just a couple of sort of empty schemas, if you will. There's really nothing in them. Public, we've got some stuff from prior migrations that I've run, but there's nothing in here that looks anything like this demo database that I'm going to migrate. So first and foremost, we should talk a little bit more about what is this application that's leveraging the database. You don't have a database for no reason at all. You have a database because applications tend to leverage it. In a lot of cases, these are packaged applications, from a vendor. But in many more cases, these are applications that you've built in-house that you're using for some purpose. It could be the application that you're selling to your customers. It could be something you just use internally, like say to track travel that's happening, or something much more advanced like some in-house manufacturing system. If you change the database, chances are you're going to need to update your application as well. Because with every database, you tend to have associated applications. Let's have a look at an application that I've custom built to leverage the SQL Server database that I want to convert from SQL Server to Amazon Aurora Postgres. So the application, being that this is a SQL Server 2008 database, I wrote it in C#. We can assume, for example, that the application has been around for many years, but in essence what it does is it's a bunch of read-write queries from the database. As you can see in here, we've got some queries written in the C# code that are reading from a SQL functions class to get the information out. If I have a look at this database or this application in action, I'm just going to build it. So build the app, all compiled. I'm going to switch to the terminal and run it to just show it to you in action. The application is simple console app, so it gives me a few different options on things I want to do. Say I want to look for customers in my SQL Server database of a certain last name. So choose option 1. I'm obviously partial to last names that start with W, so I'm going to have a look at customers in the system that start with W. So we got some Wang, a couple Wilsons, and a Wong in there, and you can see all of their information. I'm going to continue on and say I want to look at the top 10 products in the system right now. So I choose option 2. That query is run against the system, and it looks like chai is number 1 up there. And last but not least, I can see information about particular orders. Just choose 3, and I happen to know there's an order number 5 in the system. And you can see order number 5 looks like they purchased some marmalade, some camembert, and some ghee toast. I'm probably saying that totally wrong. At any rate, right now we have a C# application querying a SQL Server database. So we need to convert both the database schema, migrate the data, and convert the app. So the whole suite, if you will, of things that need to be done. So first and foremost, I'm going to go into the AWS Console and show you what we have out there. So AWS Console, going to the database migration service, everybody will have that on there. Just to save time, I'm going to show you that I have a pre-created replication server. So that's already there and running. As I mentioned, this is just an EC2 box with some replication software on there. And I've also pre-created some endpoints, run lots of different tests, quite a few, but in our case here we have a SQL Server source, and we'll be targeting an Aurora Postgres target, which is the one right up here at the top. There are some existing tasks, but again, proving that there's no funny business. Nothing in here right now. I have an old Dynamo migration and some tasks that I use for some shard consolidation, so nothing's there right now. So let's kick off and do the very first step, like I said, which is do your schema conversion. So schema conversion, you use the schema conversion tool, freely downloadable off our website. It's a client-side tool, a little bit unusual for AWS, but we're connecting to local databases generally speaking, so it made sense to have it there. And we're going to kick off and connect to some databases. So first and foremost, I'm just going to go New Project. And I'm going to say what it is I'm looking to convert. Now remember, you can use this for some data warehouse and NoSQL work as well, but I'm going to go and choose a Microsoft SQL source and an Aurora Postgres target. Press OK. I just need to get my password. It's super secure, you know, but the good thing is this is all inside my VPC, so you guys can try all you want. Check out the AWS security. The fact you all got my password, I'm OK with it. It's just some sample databases. I'm going to connect to the SQL Server instance. The information's already there because I've done this in the past. For you, you just get the endpoint information from the AWS console, put in your information, and connect. So I'll connect to my SQL Server source. And the next step, once it validates everything, I'm going to connect to my Postgres target, my Aurora Postgres target. Press OK. We're all connected. Now I'm going to go and actually first I'll explain what we're looking at here. Very much like a standard IDE, we have my SQL Server source on the left, my Aurora Postgres target on the right, and what I'm working on is going to be in the middle. So what I want to work on is I want to try to convert that demo database that I was working on, right? So remember, it was in here in the DBO schema, there were these tables and what have you that I wanted to convert. So I'll just go here and choose all of DBO, right-click on it, and choose Create Report. And what this report lets you do is see how easy or hard it's going to be to convert a particular schema. There's another way you can run this report where it'll tell you how it compares between different database engines, but in this case, I know I'm going to Aurora, Postgres, and that's why I'm just doing this minimized report. So you can see this one's a pretty straightforward conversion. Typically speaking, we get upwards of 90% conversion. Obviously, demo database is not necessarily typical, but again, all things hold true in the way that you do things between systems. So it looks like my schema objects are going to create okay or convert okay. I may have a little bit of difficulty with my procedures. So if I want to see a little bit more information about it, what I can do is I can go to my action items here, and it tells me what the issues are. So I know that there might be possibly an issue with this one because it says it doesn't support set no count. If I expand this open, sure enough, there's a problem with my procedure. I can click on it, and down on the bottom, it highlights what the problem was with my procedures. So this should look very familiar to you, what you saw earlier when I was browsing through the database schema using dbeaver. The same thing is here, and it says there's an issue with no count. Well, basically what it's saying is PostgreSQL doesn't have an option for no count. I'm not actually too concerned about this. You'll see why in a minute. But what I'm going to do is I will now try to convert it. So I'll go right up to the top here, right-click on DBO, and choose Convert Schema. Just warn something's already might be there. You know, you don't want to overwrite things unless you're sure. And now on the right, I can see I have this demo DB underscore DBO object in my target instance, but it's just in memory at the moment. It hasn't been applied. What you can do though is if I scroll down, we can have a look, say, at some tables. If I click on the address table, this is what the table looked like, or the script to create the table in SQL Server. On the right, you can see the equivalent code to convert it in Postgres. Where it gets a little bit more interesting is if you go and have a look at, say, this large order procedure we showed earlier, or I showed you earlier, there was the issue with no count. That's what it looks like in SQL Server. And you can see if we look at it in Amazon Aurora Postgres, it says basically that there was an issue because PostgreSQL doesn't support set no count, and it's just commented it out. Now at this point, if there was a genuine problem with it, you could go and edit this code here and make some changes if you want. But the reality of it is, I know that's going to work just fine in my case. So what I'm going to do here is I'm going to apply this schema directly to the database. Now you could save it as an SQL file and edit it yourself manually. I'm just going to apply it right on to the database, hit yes, and it starts applying all those objects. So now in my target database, I'm going to have this information, or rather this empty schema. So if I go back here to dbeaver, close down my Microsoft SQL Server system because I don't need it right now, I'm going to refresh my Aurora Postgres system. And now you can see I have this demo DB DBO schema with all of the tables. And of course, there is my large order function. PostgreSQL, a little bit different. It's called a function, not a procedure, but you get the idea, it's there. What's not there yet, though, is any of the data. If I right-click and read the data in the SQL console, I just have an empty schema. Remember, SCT converts the schema, DMS moves the data. So the next step is actually to use DMS to migrate the data from the source to the target. I can create the tasks manually inside DMS, but it's actually a bit easier to use some of the tight integration we have. So I'm going to right-click here, and I'm going to just choose Create DMS Task. SCT knows about the schema that we're migrating, so why not let it create the task for us? Just hit that, give it a name. We're going to call this Demo Migration, and choose the replication instance to use. So recognize that name from before. That's just my demo replication server that I pre-created, and it's using those existing endpoints that were already there as well. It can also create new endpoints if you want, but I'm just going to let it use existing ones, and I'm going to choose Create. All right, so it takes a minute or so to create the task. You can see now it says task is creating. If I switch back to my AWS console, you can see that it's creating there as well. And if we go back to the endpoints, I just know I need to make a small change to my SQL Server source endpoint. I'm just going to modify it. And I just need to change this to DemoDB, which is the name of my database, and hit modify. And with everything, you should always just test that it's going to work for you. So I'll just hit test connection. Run test. It says status of testing. Takes a second or two for it to complete. Just make sure that all the security permissions are there. It does a variety of things. Not only does it make sure you can just establish a standard connection, but it does check that the required prerequisites are there, because with DMS we do things like read login information to make sure that the replication stream will propagate from source to target. So that's been successful. I'll go in here, let's go back and see if the replication task is finished. Yes, it's been created because it now says ready. Now, there's a couple things that I need to do in order to get this to work. If I was to run it right off the bat, we might have a couple issues, and that's because in Postgres, everything is lowercase, whereas if you look in SQL Server, you can see stuff is camel case. So order item, capital O, capital I. Over here, it's all lowercase. So I'm just going to go in here and I'm going to choose modify, and I'm going to add what we call some transformation rules. I'm going to edit this one here, knowing that this is all lowercase. Change this to demo db dbo. That looks right. Save the transformation rule. I'm going to add another one where I go in here and I say for a particular table where the schema is DBO and the table name is anything. Remember, the percentage sign is a wildcard. I want to make it lowercase. So basically, for every table, change it from uppercase or camel case to lowercase, and I'm also going to do the same for the columns, because the same thing holds true for the columns in a database. Same action, make it lowercase. You can see there's other things in there. You can remove columns, uppercase, all sorts of different transformation rules that are all documented on our website. So now we've gone and we've tested the endpoint. We've added a few transformations. I think things are now going to be good to go. So I'm going to hit modify. And let's just hit resume, start task, and that should start migrating data. Now, while that's happening, it won't take too long. It's a pretty straightforward database. We should think about going and modifying the application. So remember, as I said, the application C#. I could go and modify my code manually, but it's actually much more straightforward to leverage the powers of SCT. So we've already converted our schema. What I can do is I can go to the application menu and go new application, and I want to convert a C# application. And this is just, I want to keep my parameters the same from the source to the target. That's the parameter nomenclature that you use inside the source code. And I need to point it at that directory where my application was. Now, as I mentioned, demo application, very ingeniously named Hello World. We go in here, point it directly at the source code, and select the folder. What is it we're looking to convert? Well, we are doing this demo DB one, right? So DBO, hit OK, and it's going to analyze the code for me. So here on the left-hand side, I can see my source code tree. Go in here, and I know that all of my SQL code is actually inside this file called SQL Queries. So I'll just select that, and you can see here we have, I'm just going to move this over so you can see it a little bit clearer, the original and the new, left to right. What I can do is I can hit Analyze, and it's going to scan through my source code and identify SQL statements and rewrite them from SQL Server syntax to Postgres syntax. So I'll hit Analyze, and it's found 3 statements. So what I can do here, select the statement and convert it. So it converts it from SQL to Postgres, apply it to the target file, and do it for the next 2 as well. Convert, apply, convert, apply. All right, that's all done. Hit save. It's all converted. And now I'm going to go back and make sure my application has finished. Looks like it says load complete, or not my application, my migration. So you can see we've moved things over. Quickly switch to dbeaver to show you that there's now information present in the system. There we have it. We have our addresses migrated across, and the information in the other tables are there as well. But where things get interesting is if I switch to my application, you can see now my SQL queries have been updated, right? So these are now using Postgres syntax. I just need to make a few small changes to get it to compile properly. So just fixing up some of the, commenting and what have you. So we're looking to pull out of the customers table. Just change this. This just takes a second. Certainly a lot easier than having to convert it all myself. Okay, so that one looks good to go. We're going to do the same. This is the top 10 active products. You remember me demoing this previously. Straightforward query. You see it's got the new schema in there. The table name is lowercase like it's supposed to be for Postgres. And that's all good to go. And then the very last query is this order details query. We're looking to pull out information about the particular order. So I'll just modify this again. You can, of course, format these things any which way you want. I'm a little particular, so just got it, just modify a couple last things. All right, and you can see the main thing I need to do here is just replace this so the variable will get entered into the query dynamically. All right, so now these queries are good to go. Oh, one extra quote in there. There, that should work. Now, one other thing that I need to do. This SQL function, if you will, or class, I should say, contains my queries that read, or the functions that query the Postgres database. I'm going to quickly switch over to here and show you how this works. I built two of these just to make it easy, although traditionally speaking, you would probably modify your query class or query function instead of creating a second one. But this is, if I scroll down, that's my update, hold on, sorry, wrong one. Scroll up, I should say. We have a standard select SQL function. Anybody that's written this in C#, it's going to look pretty familiar. A SQL command, reader, what have you. This is how I'm reading from my SQL Server database. For Postgres, essentially the same stuff's available. If I go right up at the top, you can see that I have, this is the SQL System Data SQL Client is the .NET provider for SQL Server. This NPG SQL is the same kind of thing. It's a .NET provider for PostgreSQL. So then if I go back down and look at this, the select PostgreSQL, you can see it's very syntactically similar to what you were used to doing with the .NET SQL Server provider. Just, a few different commands. NPGL SQL command and a data reader, same deal. So all that means is if I go back to my queries class, to get this thing to query against Postgres, all I need to do is change my select SQL query call to select PostgreSQL. And likewise do it for these other two. And finally, last query, go in here, dot select Postgres, right? So now the queries have been updated to use Postgres syntax, and the function that's calling the database is now using the PostgreSQL query. So I'm just going to save this, and I'm going to build it. Control-Shift-B to build. It has been built, and we should be good to go. Terminal, and I am going to run it. Okay, same thing. Customers filtered by last name. Well, let's try a different letter this time. Let's go for S. And there we have it. We've got the customers out of the system that have a last name start with S, and top 10 products. Great, we've got those products there as well. And last but not least, our order details. So let's choose order 4 this time. There we go. We got order 4 with some hot pepper sauce, so that looks pretty good to me. So there we have it. We've converted the schema using SCT. We've migrated the data using DMS, and we've used SCT to convert application code inside a .NET application, compile it, and query the information out from the migrated Postgres SQL database. So it really is that straightforward to migrate everything from one database engine to another. The same theories and procedures will hold true for you and your applications, and you can use these easy to use and free tools to do the migration, because SCT is totally free and can help you convert between various different database engines. So hopefully that was interesting and you guys enjoyed the presentation, and thank you very much for your time today.